Porosity of the soil, technically defined, is the volume of pores or empty space per unit volume of soil. For its practical purposes, porosity is extremely important on a day-to-day basis for agriculture, for many different societal uses and processes that go on in the environment. As you can see from these two clods of soil I have, they look like they're completely solid. If you take a typical soil clod, about a handful worth of soil, about 50% of the volume that you're holding is solids. The rest is pore space. Well, we're going to prepare outside for this lab activity that will be conducted inside. And so one of the things that a soil scientist does is spend a lot of time in a soil pit. And we're going to grab a couple of soil samples from the topsoil. You can see the upper portion of the soil profile that's a little bit darker in color. That's where the organic, rich material from the roots turning over every year are concentrated. And we're going to collect a soil sample from the subsoil down here that's a little bit browner, lighter in color often, maybe reddish, orangish, where there's less organic matter. So on the topsoil here, we're going to just pull out a soil clod, and then we're going to go down here in the subsoil, and we're going to try to pull out a clod of soil that we can use. So we're going to take this spray bottle of lacquer. I'm going to just pick this apart so it'll nice and easily fit into a beaker, and I'm just going to give it a light spray of lacquer on all the sides just to hold this material together. Back from the field we are and into the laboratory. We've collected our soil clods from the field. We've applied the thin layer of lacquer spray finish, and we are ready to do our little porosity test in the lab. One of the first things that you want to do before you actually submerge your samples is make a hypothesis to try to anticipate what you expect will happen with this little test. So here goes. We're going to drop our topsoil piece into our beaker and watch the air bubbles rush out quickly. We're going to drop the subsoil clod into the beaker, and we'll similarly observe. There are air bubbles coming out of both, still more rapidly out of the topsoil. They're starting to slow down already for the subsoil clod, and you want to use your stopwatch to periodically, every 30 seconds or so, up to about 5 minutes, record some observations. And you can think about how that relates back to natural processes that go on in the environment. It allows water to drain on down through the soil profile to eventually encounter groundwater. And groundwater is important because it serves as a drinking water source for a large population of rural residents, particularly in Arkansas. And the soil, particularly the pore space and the porosity that the soil possesses, plays a very important role in all of those environmental processes.